All right, so I'm going to do a very, very quick presentation on why blockchains are not computers. And I think the hope of this is that you guys can learn something and also understand what we're doing and what we're about. So the first thing is, there we go. Who am I? Why should I talk about why a blockchain is not a computer? Why the hell is that important in 2023? What's going on? So I've been developing on Ethereum since like about 2015. I built many libraries. Some use the MetaMask, for example. I built a language as well. I was at Consensus very, very early on, and as well, I built the first optimistic rollup to mainnet Ethereum, so that's Fuel v1. And as well, I'm the founder of a layer 2 scaling system called Fuel. And yeah, that's a little bit of background about me. I think the main thing to say when it comes to blockchains is that blockchains are extremely complex. There's a lot of things going on. There's a lot of complexity built into the system. And this is particularly important when you're trying to understand what it is not, and what are the right technologies to use to scale it and to bring it to the entire world. So blockchains typically include a few key properties, some of which I'll just mention now. So anti-Sybil mechanisms, right, preventing spam. This is very important as well. They include something like a state transition function. So you need to be able to move the state of the chain forward over time. This is in many ways encapsulated in blocks and transactions. And in many cases, a state transition function for blockchains has a virtual machine. And I'll explain what that is in a second. And as well, there's mechanisms of access and communication. So typically, peer-to-peer layers, communication layers, etc. So these are some typical properties that we see in blockchains themselves. But the most important thing to look at for this presentation is that state transition function, right? How do we move everything forward over time? So we're seeing a lot of blockchain tech, whether it's layer 2s, layer 3s, or layer 1s, and many of them are starting to experiment with low-level or general-purpose runtimes. And so, basically, I think some major ones to call out are things like MIPS, x86, RISC-V, WASM, etc. And on the front of layer 2s and proving, some of these general-purpose runtimes kind of make sense. So there's, it's not too crazy to say. But in terms of actual smart contract runtimes and how we're building smart contracts and how do we get these to the entire world, we're seeing a lot of WASM typically. And when you're talking about these virtual machines and runtimes, right, these are the things that run smart contracts. What's the problem with using a general purpose runtime like WASM? We've been using the EVM forever. That's a virtual machine. That's the Ethereum virtual machine. Now we're kind of seeing a lot more things like WASM. So what's the problem? Well, you have to really ask yourself, are these architectures really designed for the job of what we're doing with blockchains? Are these architectures built from the start to support what we do with blockchains? And that is fundamentally the question you should ask yourself, because we really have an opportunity in this space to do whatever we want with things like layer 2s and execution environments. So we have to ask ourselves, are they designed for the job, right? And when you look at some major ones that we're seeing, things like MIPS, x86, which in part is used in a lot of things like Solana and stuff like that, RISC-V, or WASM, which you're seeing in certain layer 2s, they're really designed for something else. So MIPS, x86, RISC-V, these are designed for CPUs. They're not designed for blockchains, but we're using them in blockchains all the time, like, hey, this is an amazing thing. Let's use this thing because a bunch of languages target it to make our smart contracts. And then you have something like WASM, which was designed for running arbitrary code in the browser, not for blockchains at all. And so, we like to use it. It's okay. The space is experimenting with it. And I've been waiting for eWASM since like 2016. So for me, trust me, I've been there. The wait was real. But are they really designed for the job? I'd argue not really. What are the jobs that these things are designed for? Well, everything else for sure, like video games or browsers or editors or email, whatever you want to use. But Are they really designed for blockchains? Probably not. This is really the job of a computer, is to do these kinds of things. This is not what we do with blockchain in general. So what is the part of the job that blockchains are typically doing? What kinds of things do blockchains do on a regular basis, right? Well, some things you might see in the space, exchanging, right? Exchanging one token for another, voting, crypto, verification, maybe storing some kind of state or as well just like arbitrary logic. So, the bottom two, very general, but, these are sort of parts of the job of what blockchains do for sure. But what do blockchains really, really do? What are we all here for? What is TOKEN2049 about? What is everything about? Why is this even existing in the first place? And it's assets. Everything's about assets and tokens. It's the whole reason any of this actually works. If you have blockchain, but you don't have tokens, there's no blockchain, because it's just an interesting peer-to-peer system, and that's it. You need assets. Assets are fundamental to the entirety of the space. And to have architectures or virtual machine architectures that do not factor in assets at a fundamental level is a massive, massive opportunity miss. And the opportunity miss is pretty substantial in terms of the downsides. So when you look at general purpose architecture like WASM or these other things, it basically means that if you want to support that, that's wonderful, but you have to build every application, or you have to build every token at the application level. This is really horrible. We've been doing it with something called ERC20, that's a standard. We've been doing it with all kinds of different application interfaces. But tokens fundamentally are even more native than this. So building at the application level actually really sucks in many ways. Lower level concepts can't be represented, right? Key optimizations are missed when you don't actually factor in what we do with blockchains, which is process tokens. Many, many different kinds of all different flavors at the native level. And as well, poor interface design happens because we don't really know what the expectations are, and then lots of bad things start to happen, like reentrancy. And as much as reentrancy is actually a pretty solvable thing by all standards, we continue to see it over and over and over again forever. And it's because if humans can make a mistake with an interface or an implementation, they will make the mistake. And so really, even if you shut reentrancy off in something like WASM, you haven't really solved the problem because you're still not solving the fundamental issue, which is assets really are things that need to be first-class citizens in blockchains. And so, when you look at these things, what is the solution? So we have general purpose runtimes to build smart contracts, very interesting. We know, though, that blockchains are really fundamentally used for assets, and we should really support them as first-class citizens. So what's really the solution? Well, you should really look to always design the right tool for the job. So the thing is, it's always easy to just use the EVM, even though we know there's so many flaws with it, but a business person will tell you, use the EVM. The EVM is what everyone supports, so do that. Don't do anything that's right or maybe that'll fix everything. Do that, because that's what you'll get supported. Or use WASM, because everything already supports WASM, so do that. That's what a business person says. And there's a lot of business people in the room. Love business people. We need them. They're great. But are they really solving the problem? Is it really the right tool for the job? And this is where Fuel, my project, comes in. So Fuel is really designed to be the first asset-centric roll-up on Ethereum. And we actually are, in many ways, and I'd argue that because we designed and built the first actual asset-centric roll-up on Ethereum to mainnet with all the pies of the security standard fulfilled in Ethereum. So I'd make the argument we were the first two. But in many senses, asset-centricness should be designed through the whole system. And yes, general purpose and low-level runtimes are amazing, and we should have them, we should understand those things. But if you really want to solve the problems of blockchain, you need to build the right tool for the job. And that's really what Fuel is about at every single level of what we do. And so a very quick summary of what Fuel is, and I'll just try to explain it too because I didn't add enough slides. Fuel is really trying to design the right tool for the job for what are new blockchains, layer 2s, layer 3s, modular blockchains, and execution layers. the main thing that we focus on is having asset centricity through the whole stack. So everything is about assets. And when we have our virtual machine, it'll be as or more efficient than Move or Wasm, but it's really, really good at transferring, creating, and minting assets. And doing it in a way that is parallel processed and that can support global volume. And so the Fuel VM is inherently trying to treat assets as first-class citizens while giving you all of the nice general purposeness of what you see with things like Wasm, etc. As well, Sway is a programming language we built from the ground up as well. And Sway is really designed for safety and efficiency, but it's to give you a design experience that is not something like Rust or a systems language that, again, is not the right tool for the job. You really want a language that's designed for blockchain, designed for these different aspects of what we need them for. And as well, a tool chain that does everything you actually want it to do, whether it's everything from testing all the way over to static analysis, publishing, or taking your application, deploying that as a layer 2 or a layer 3 or a sovereign chain, etc. We've made everything all in one into one single system that addresses wholeheartedly and truly all the issues that you see with the space. And yes, it's very difficult to do what we're doing because we rebuilt everything from scratch so that we could design the right tool for the job. And yes, all these other layer 2s are bigger right now and all these things are very exciting, but we won't stop until we actually design the right tools for the space. And that's everything that we do, and the commitment that our project makes to the crypto community is that we want to build the right tool for the job for building crypto and for building assets. So if you want to learn more about Fuel, go to fuel.network. It's our website. We are going to update it soon. We just released a new docs portal with everything all in one. And that's the presentation. Thank you so much. So I think I have like 2 minutes for questions, if anyone wants to ask questions. Yep. Oh, sorry, they got a mic here.
So in recent years, RISC0 and Cartesi have tried to build general purpose programming models. I see a lot of that going on in the ZK space.
Yeah.
So how do you see those types of programming models evolving, and where does Fuel sort of stand out compared to some of those approaches?
Yeah, so the way that I'd explain it is this. You're going to see a lot of general purpose solutions come out for blockchains, whether they're ZK provers or whether they're layer 2s that support Wasm, and that's amazing, that's wonderful. However, I think the key detail is it will be more efficient sometimes to just build whatever you want to see in Rust or something else and just do that. We can always do that. The issue is when it needs to interface and play with all the other applications and there's assets involved and there are things being transferred between all these different protocols, all of a sudden all the problems begin. Why can't I just write my application in C and just have everyone interface with it? Because the interfacing itself, the token models, and as well just how you're transferring these assets in parallel, scaling that globally becomes the actual issue. So you can build things in isolation easily all the time, and general purpose runtimes are amazing for that. However, when you really get down to what we're doing with blockchain, what we're doing with these systems, you really need to design the right kind of architecture for it to interface with, and that's why using something that's designed for the job, like Fuel VM or Sway, is really the most important thing you can do as a project. Instead of just designing for your own need in isolation where nothing can properly interface with it. So that's the way I would explain it. Okay, I think that's it. All right, thank you so much, everyone. Yep.